Good morning to all of you. This is the 41st webinar of IJS Guntur chapter, organized by one of the student chapters under IJS Guntur, Chalapati Institute of Technology, Mothataka Guntur district, Andhra Pradesh. IJS Guntur chapter established in 2003, organized a number of seminars, workshops. Significant being IGC 2009 National Conference held at RVR at JC College of Engineering, Guntur. I am thankful to Professor S. Mohan, IIT Madras, Professor Department of Civil Engineering, has come forward to deliver this second lecture, Data Mining Applications in Civil Engineering. I am thankful to him because on his own he came forward to deliver second lecture. And before introducing the speaker, a few announcements to participants. I request you all of you, please stop your video. And during the lecture, you are going to chat with the host only, that is myself. And you may chat audio and video issues only during the lecture. Please do not share your information and questions during the content of the lecture in PDF and your feedback. And in the feedback, it contains even suggestions related to the future webinars, titles, speakers, details also. So that we have introduced, that is few days back, that is 2 weeks back. And with that, we are getting a lot of information from the participants and we are able to plan so many webinars. And question answer session at the end of the lecture through chat. Our next webinar tomorrow at 11 a.m. that is on 9th Thursday, Mitigating Foundation Distress by Mr. Sanjay Gupta, Managing Director, Sengras Geotechnica Private Limited, Noida. Now I request Professor Kolla Nagasrinivas Rao, Advisor to IJS Student Chapter, to introduce this speaker. Nagasrinivas, please unmute yourself and introduce this speaker.
Thank you, Ramarao Garu. Good morning to you all. Welcome you all to the 41st webinar of IGS Guntur, organizing by IGS Student Chapter, Department of Civil Engineering, Chalapati Institute of Technology, Mothataka, Guntur. And the speaker for the today's webinar, Data Mining Applications in Civil Engineering, is an eminent person, Senior Professor Dr. S. Mohan Garu. It gives me great privilege in introducing Dr. S. Mohan Garu. Dr. S. Mohan is currently the Institute Chair Professor in the Environmental and Water Resources Engineering Division of the Department of Civil Engineering, Indian Institute of Technology, Chennai. He obtained his Master of Engineering in Water Engineering in 1983 and PhD in Water and Environment Engineering in 1987 from Indian Institute of Science, Bangalore, and became a faculty member of IIT Madras in 1987. He did his postdoctoral from Cornell University, New York, USA. As of 2019 August, he has published over 200 articles and technical reports on several topics of environmental and water resources engineering and science, including water and wastewater treatment technologies, environmental nanotechnology, environmental impact assessment, water and air quality modeling, contaminant transport in surface and subsurface water systems, sustainability engineering, reservoir operation, water resources optimization, waste to energy, waste to materials, and solid waste management. The H index and the citation index are 19 and 1504 respectively as of May 2020. He is a recipient of several publication awards or recognitions, including Pennycook Award, Institution of Engineers Award, Indian Waterworks Association Award, etc. He is currently the Chairman, State Expert Appraisal Committee, Tamil Nadu State, and serving as an independent director of Tamil Nadu Small Industries Development Corporation Limited. He is a research cluster leader in the area of environmental and water resources engineering and provides a contiguous value chain of research, translation, development, and application of environmental and water technologies. He has guided 23 PhD scholars, 10 MS scholars, 67 MTech projects, and 28 BTech projects. Currently, Professor Mohan is guiding 14 research scholars. He also provides advisory services to the public institutions, professional organizations, environmental and water industry, and non-governmental organizations with the mission of improving the living conditions of Asia's developing communities. I express heartfelt thanks to Dr. S. Mohan Garu on behalf of Chalapati Institute of Technology, Motadaka, and IGS Guntur chapter for accepting our invitation and presenting this webinar in spite of his busy schedule. Thank you, sir. I also thank Dr. M. Ramarao Garu for showing keen interest in organizing these webinars. Thank you, one and all.
Sir, dear sir, please start the lecture.
Yeah, right. A very good morning to all of you. I am really thankful to Professor Ramarao and also Naga Srinivas Rao for making this event as a fruitful one. So thank you very much for giving him an opportunity to share the new topic. Especially my interest was that people can start doing research using these tools. So that's the main reason that I thought that it will be very useful, especially in geotechnical engineering. So the data mining, which is a very new area of research, and its application in civil engineering, but I was thinking because it is IGS, I should give an example from geotechnical engineering. So I could make one example from geotechnical and one from solid waste management. So these two examples I will be telling. So my lecture will be covering as first to understand what is data mining, then what is data mining life cycle and data mining processes and methods, and two case studies. One is leachate prediction from a landfill and a pile capacity estimation. So based on the past data. So these are the two examples I will be giving. If time permits, I can slightly give the screenshots of the software, what we are using it. So that's the main aim of this particular lecture. So we should always understand, I think this statement is very nice statement, which I like it. All engineers and scientists are data scientists. So somehow you have to deal with the data. So how you interpret, how you get the information from the data, or how you are using very intelligently the available data is real engineering knowledge. So that's the way that you may have to look at it in as an engineering view or scientist view. I think data forms a great importance. So data mining, which is nothing but trying to get the knowledge discovery from the data. So whatever the knowledge which may not be directly visible in a system or in a mathematical model, what we are trying to look at on a non-trivial, implicit and useful knowledge from the data sources. Wherever you collect data, maybe what you may be collecting from entire Andhra Pradesh or Tamil Nadu or entire India, trying to use that particular data and then develop some knowledge on that. So this has a lot of applications. It started with marketing, or even these malls, they use quite a lot on the data mining, and medical, they use quite a lot on data mining, and engineering also, there are a lot of good development. And thanks to the computer science scientists and engineers who have come out with a tool, which so that the civil engineer, we need not look on how to develop a software. So in a very simple words, data mining is just try to take the diamond out of the basic kind of a coal or whatever it is. So this is what which may be hiding inside. You try to come out with a diamond. That's the main idea of data mining. So again, I am repeating, data mining is, it may look like a coal or maybe a kind of a system which may be there underground. So, but you come out with a diamond which may be hiding there. That is what is called data mining. So now let me look at, so this is why to study the data mining, or it says the Harvard Business Review, it says that it's a sexiest job in the 21st century. Okay, so don't imagine too much, but if sexy means having rare qualities that are much in demand, the data scientists are already there. They are difficult and expensive to hire, and given the very competitive market for their services, difficult to retain. There simply aren't a lot of people with their combination of scientific background and computational analytical skill. So this is the best job now in throughout the world that it is there. Okay, so sometime if you start working on this data mining or data science, I think there is a very good opportunity for future years. So especially the young people have to take lead on this particular one. So as I said earlier, it is more on the knowledge discovery and data. So there is a process, and also there are some challenges what it is there. The process is, from the data, you use a tool of data mining, come with a pattern or a knowledge, and then they interpret the evaluation and apply the knowledge and work on that, and that forms again a feedback in your data. Okay, so this is a simple cycle. It is not that we go by a linear way, but also as a cycle as such. Okay, in fact, the data mining started with a very simple example. So I don't know, all of you know Walmart. Walmart has done a small exercise with a data scientist with them, that what are the customers kind of behavior, what are they that they are going to buy, okay, as a person that it is. So they just put the customer, I am just putting a simple example like this. There are, per day itself, you may get more than um, uh, more than a lakh customer that may be coming. So they found that customer 1, customer 2, customer 3, and they find a pattern that whenever they get a pizza, they also get a beer. And so that means there is a chance that means you try to keep that nearby rather than putting at different corners of the mall. So this is the first thing that they have done. So keep nearby to that. So the kind of sale has increased quite a lot. Then they also find, if pizza and beer are in one purchase, it is likely that chips are also in that purchase. So you can just see, whenever pizza and beer are there, then there is a chips that it is available. So I think this is a very crude example or a simple example. In fact, they have increased their profit almost around 50 times, or 50, more than 50%, not times, 50% by just putting the place wherever there is a coherence on the purchase asset. So that's a very simple kind of a logic, which may not be, nobody thought that this bill will be, but you also remember that you are going to buy, and these are all become a record. Okay. So this data nowadays, we are, even if you take a mall or maybe a cinema theater or maybe a textile shop, whenever you are going, there is data what it is being generated. Now we are also in India, also everywhere it is computerized. It is not like in the olden days that people do that. So you have a volume of data. This is called a big data. And also the velocity at which that it comes, the stream is really very high. And also the variety of data. It may be a transaction data or temporal data or spatial data or spatio-temporal data and so on. So we get data wise, it is not a big problem at all. You get a lot of data. So earlier days, the days have gone that I collect data and then keep it myself. So now it's better to put on the thing. You can see an example of Facebook. Earlier, nobody wants to tell where he is going, but now it is other way around. Every time he says wherever he is going, it is in the Facebook. So the data is available. So it is almost like what kind of a data that you need, it is going to be available in the net. Only thing is you have to correctly select the data from there. So even a number or maybe a car or maybe just so it is data is, if you look at the definition, it's just a collection of facts. It may be a small data and it can be a structured data like what we do in a testing or testing a file. So there it is a small and structured data. But on the other hand, if I take the entire file data of the whole country, then it becomes huge. And sometimes I may put in a different format and someone else from Delhi will put in a different format. So it becomes a huge data, but at the same time, unstructured data. So one has to really look at it first to make this data into a structured one. So you may have to spend a little more time to make it. Once I make it as a structured data, then I'll be able to apply the techniques. Okay. So the data comes from everywhere. So even your shop or your hospital or weather station, social media, or any testing, what you do, okay, earthquake testing or market or share market, anywhere, even if you are going and buying something or selling or meeting, all these data becomes at one point or other, you will be getting a lot of data. And now we have to wisely utilize this data for the benefit. That's the main idea of this data mining. So if you look at our current situation, wherever we go, we are datafied. So our data is going inside. In fact, you may not be knowing whatever the purchase that you are making, what brand that you are making, it will be available in the net. So next time when you go there, the salesperson will tell that directly take you to that particular brand. Yes, he knows that this is a brand that you like it. So now almost all the purchase, your data, somebody is looking at it. Okay. The smartphones are tracking our locations. We have a data trail in our web browsing. Interaction in social network also become a data. Facebook tells about history of our activities. All you buy from supermarket, including the brand, frequency of visit, amount you had spent, all are recorded. Sometimes privacy is an important issue, which is now people are working on it, but it's not governed in this lecture. But we have to also look at it. This is a very nice joke, what has been given. Where the heck is my data? Somebody is asking. Now it's there up in the cloud. So every data is going to the cloud. So from the cloud, anybody can download. It is not only that from India, from anywhere in the world, they can download. So your own data, you are not the custodian. Somebody else or anybody can take this data. So now it becomes such a way that the data subjects are available everywhere. So the collection of records, so there are record data, which is a transactional or sometimes temporal data as a time series data or sequence data. Spatial, now the spatial data also available, graph data, unstructured data, and semi-structured data where paper publications and XML format. So now if you look at it for any area, civil engineering and or any branches, you have a lot of data. Okay, so in fact, I was just searching for some data on file testing. I could get it very easily, which has been some work which has been done in University of Ohio. So I'll be that way, then immediately I can take the data and then try to do a model within no time. So now we may have to go in for that kind of a data mining. So you can have a data in a matrix form or in a vector form or the transaction data. This is a market-based customer want to thing. And also a spatial data. So if you look at the monthly temperature, so over the space, how it is varying, and you can have a color code, or even the spatial distribution of objects, a particular type of tree where it is there, and so on. So user movement data. So your movement itself, you can easily find out what you have done on a personal weekend, from home to swimming pool and then stadium and then movie complex. Then it is coming back. So even your parents can make a note on where you are going. So now it is possible that you may be giving, but it can be listened by many people, or you have a connection with. Suppose I am watching a Netflix movie. My son who is in USA can say that what movie I am watching. So that way, all the data are becoming now, it is more explicit. So this is a structured data, unstructured data. Unstructured data, it is not explicitly directly given as a table, but you may have to collate information from the unstructured data. So this data mining is a very nice concept. It uses machine learning, it uses the statistics, it uses the artificial intelligence, database, like there are many database what it is available at a data science, and other technologies, optimization, everything has been included in the data mining tool. So there are many tools are available, but you can use any one of the tools. There are many tools which are freely available. There are certain tools like IBM SSP, that will be, you may have to pay amount. But one of the good thing with that is very good visualization, high performance computing. You can get the data from cloud or put the result into the cloud. So the cloud also can do the computing. So now a good definition or a comprehensive definition is data mining is an interdisciplinary subfield of computer science. It's a computational process of discovering pattern in large data involving methods at the intersection of AI, ML, statistics, and database systems. So you are really using the best out of the new technologies. So that is what you may have to be proud of using as a data mining. So nowadays, data mining can be used for even if there is somebody take your card, and you can easily find out where he is going and what he is doing. Or if even you can track a mail or tagging a mail as a spam or genuine, that also can be done with the database. So you can know that from where you got the data or the mails. And if some mail is a bogus mail, then you can easily say it automatically goes into the spam. They do a data mining. So let me just look at tell the data mining life cycle. So first is step in that is data acquisition. So the data acquisition you can get from multiple sources. Sometimes you have PDF file or maybe from cell phone or computer, and you try to store it in a structured way. And finally what you want as a target data. Not all data what it is coming from different section may not be using. So you choose the data and then try to store it and make it as a target data. In fact, this and data processing they take a lot of time in data mining rather than applying this technology. So it is more how best that you are preparing the database that makes how the kind of pattern that you will be getting it. So here the data pre-processing, you try to find out the visualization, look at the outlier, and here we don't remove the outlier like in statistics, because here every data is valuable. If one outlier is there, why it has occurred, and there may be a pattern within the outlier itself. So one has to really look at on any data is useless is not the concept here. All data or each and every data is useful is a concept. So don't leave out some outlier. So outlier also, there may be some knowledge in that particular outlier itself. So that is what data manipulation is arranging. Don't use interpret in a different way, but it's more on that database creation or arranging it. Then you apply the machine learning algorithm. So this machine learning algorithm has many techniques. It is classified into classification, regression, clustering, and there are many more things which I can, but these are the three important things that which are normally be used for any data mining. So you use one of these techniques, or the best way is you apply all the methods and find out which method is performing better for your data, because you don't have any idea of whether this data will be good for clustering or this data will be good for classification. So the best way is you try to look at on first level cutting. Then if you find that classification is good, then you can go for fine tuning that particular classification. So once from these analysis, I'll get a pattern. So this pattern, you try to evaluate it. Go with some more big lens and then find out whether I get some knowledge or some rules or rules of operation. So that where we try to come out with a knowledge representation, how it will be there, or given the conditions X and Y, this will be the Z. Like that for various situations that it will be there, it will be possible. Okay. So on the other hand, the data mining process has this, the data warehouse, or where you store a lot of data. And from that, you select what data that you want and put it in the target data. Then you look at the pre-processing. Then after pre-processing, data mining, then interpretation, then come with the knowledge as a pyramid. Okay. So these are the parts what we will be doing in each one. In the selection, you try to select the relevant data set, independent variable, or sometimes you do the principal component analysis, or you try to find out which can be independent variable, which can be dependent variable, and how many records that it is available, and what distribution that it is there. These are all can be done in selection. Then pre-processing is integration of data from different data sources, because each one will be in different format. You may have to put it in a singular format and make it sometime we may need to normalize, because one data may be very high values, another may be 0.6 or less than 1. Then all of them should be normalized, or noise removal, or missing values substitution, or dimension reduction. These are all pre-processing. So you should have a basic knowledge on the basic statistics on PCA, or and then you try to look at on how to fill up the data, how to noise removal, or how I can reduce the dimensions using PCA. Okay. Then transformation. So you can make a transformation also. So maybe you can just convert them into uniform pattern, or try to reduce it with the, but nowadays you need not do or make it log transformation if I want to make it normal distribution. So the log may, so this is something, the transformation. Then you do the data mining. So data mining as such needs these three steps: selection, pre-processing, and transformation. In the data mining, so you try to look at on, is there some pattern that it is existing? Okay, so that's what we may have to look at it. And what method I am going to select: pattern selection, pattern evaluation, pattern interpretation, and pattern visualization. All of them part of the data mining. Evaluation is you try to apply that to a new data or new situation. Try to evaluate whether the rules or the pattern what you have developed is reasonably good. So then if it is not good, then I can go back. Even if it is good, send that also as a part of the data. So then you get a good knowledge on that. So I hope you understand the different steps of the data mining. So this pre-processing, sometime you may have to also make some data. Suppose I have around 300 data, maybe 200 data I will use for training, and validation I can take 100 data. And only thing is, don't try to be with your own enthusiasm. Do not overfit the, sometimes overfit also in statistics will lead to a lot of problems. So sometimes if you are putting overfitting a linear when it is sinusoidal, then it becomes a problem. So one has to really look at on the beware of overfitting when you do the pre-processing. Then in the data mining, there are two type of techniques that it is available. One is predictive. If we want to do future prediction, what it will be there. So for new set of data, then you can use the best technique. What it will be used is regression and classification. Classification again, neural network, Bayesian network, Bayesian tree, support vector machine. In that support vector machine has been a good and collaborative filtering. These all will be for predicting. Whereas you want to understand the system and how each variable is related. What is the connectivity between the different variables? So for that, you can use association rules, Bayesian tree, random forest, random tree, rep tree, M5 rules, and deviation detection, statistical analysis. So you can use for, depends upon your purpose, you can use if you want to predict what it will be, or understanding the system, both are needed for research. So you can utilize that way on that. So here again, the predictive method, I am just giving what is classification. So given the data, you try to make it different classes or kind of grouping together, that will be better, and learns a method of predicting the instances based on some interval. If this falls on this interval, what will be the result? If it falls on x equal to this interval, what will be the result? It may be different. Whereas regression is, you try to, all of you know what is regression. Clustering is another very important thing. It is not only grouping, so it is not that vertical for different interval I make a thing. I put the data and then group it into different cluster. So this need not be always for a particular interval. The data can be, the last data may be in here, or the first data can be in the third cluster or fourth cluster. You can go for as many other clusters as such. And association rule is method of discovering interesting relations between variables in large database. Okay, so this is what it is there. So people have used, if you have time series data, people use clustering, like medical thing, they try to find out normal, or if there is a problem that it is there, or motif discovery, or if there is a pattern rule discovery, and query by content. So novelty detection and visualization, all of them are possible if we have a good time series data. On the other hand, if you have a trajectory data, trajectory is when it occurs, what way that it will be moving, like monsoon or whatever it is, or cyclone. Then also you can use clustering, motif discovery, frequent travel patterns, and classification visualization. So there are techniques which are available. So you can use whichever is more suitable for your system. That will be more appropriate that you can select. So this is a theoretical thing. So if it is more on try to find out why independent variable, y is dependent variable, x is independent. So you try to fit a linear or k nearest neighborhood or artificial neural network or polynomial curve fitting. So anything that you can do, which is all available very nicely. So on the other hand, there are many classification algorithms, Bayesian trees, nearest neighbor, support vector machine, ensemble, Bayesian classifier, neural network. And people are now doing a lot of research on improving this or combining some of these techniques like neural network supported by support vector machine. Okay, try to find out a relationship like, smoke and cancer. You like that, you can come out with some good kind of a relationship that it is going to be available on this. And the clustering is nothing but, suppose you have a lot of data and you can cluster like, in these 3 cars and 3 bicycles, you just cluster car separately and bicycle separately. So that's a very simple way to explain, but there are many methods to do that, even grid-based clustering, model-based clustering, or partitioning, or hierarchical method, which is commonly used in this, and ensemble modeling and constraint-based method. There are many ways that you can do the clustering. This is one good technology that you may have to learn and then work on it. So this is association rules are where you try to understand the process. So and then try to come out with, suppose, based on the data, you try to the frequent item sets, which are milk, bread, cereal, milk, bread, cereal. You classify the data. You can also come out, suppose, all the people have taken these 2. Then I can always put 100% that rule what I am getting it. On the other hand, out of the 100 customer I am checking, if only 80 people have done it, then I can put the reliability of that particular data also as 0.8. So like that, you can always go for some good kind of thing, not only in that. So this is what if condition, then result, what the consequence. So this is a way that I can develop lot of rule. It will automatically develop. And you only thing is you have to give the data. So which is normally it is now available. All our transactions are available in the net. So the Dyson trees and visualization and data mining. So you can have a summarization. That's also possible. So I draw your attention that you have, these are all the tools which are available. So several options are commercial or free or open. So you can just check up with these KD nuggets. So there are software suites are available. Commercial tools are offered by IBM, Microsoft, Oracle. The open tool, these are maybe, which are very important and you can download it. Weka is the most useful one, which we have used, and are also equally people are using quite a lot. And is SciPy and NumPy, I think Orange or Elkey, okay, environment for developing KDD applications supported by index structure. So Elkey and RapidMiner. So these are very both are available, free and commercial, but free have some limitation. So kindly make a note. You can download it. You just put Weka in the Google, and you can freely download that very easily. So let me, having talked about what is data mining, please understand that even the data, if I don't utilize it, it will go as a waste. And you have unnecessarily collected the data, stored it in the computer. Please use it with some data mining. That is what the data mining concept that it comes. So what I have done, this work has been done by us. Okay. So one is on a landfill mainly on the leachate, what it has been collected. So, so the landfill leachate depends on rainfall or how much height that it is there, what's the density or what is the compression index, all those things that we could collect the data, and using that data, we try to come out with a data mining model. Okay. So the why we have taken this landfill is one of the MTech student study. The number of landfill sites are increasing in association to urban expansion. The growth of open landfill, it is not I won't say landfill, it is a dump site subjected to climatic conditions generate huge quantity of leachate. The leachate had been termed as one of the most common contaminant, thereby influencing the groundwater aquifer over the time period. It's not only the groundwater aquifer. So landfill or open dump site, where we always quote as an example, where you want to look at air pollution, water pollution, land pollution, you go to the landfill or open dump site. Because air pollution also is there because a lot of burning which is going on. So the treatment of leachate generated from a landfill had been one of the more explored research domain, but for that we need to have a good generated leachate generation data. So we try to find out, develop a model which can predict the leachate generation, because every time we cannot go on measuring the data in the field. So that's the main reason that we develop a model. So the leachate treatment and characterization. So these are all very important. So we have taken some 3 landfills, landfill A, B, and C. So the data what we have collected, landfill A, 55 data sets, landfill B, 46 data sets. This is 108 data sets. Landfill D, even though there may be some problem in data collection or something, there is a poor correlation among the dependent variables and independent variables, and that's why I'll be talking about only these 3 things. So the landfill, so we try to find out the rainfall, quantity of waste, and moisture content, and compression index. Compression index, because these can have a lot of combination of different things. So we try to look at on that the coefficient. So these coefficients also it has been checked up. So if you take the landfill A, we try to find out this is the quantity of waste. Okay, so this may be the quantity, and this quantity, how it is correlated with the this rainfall, then month, and compression index, and the moisture content. So sometimes it is not only the rainfall on that particular day, but it is a previous day rainfall or previous week rainfall. So we have tried different combinations, and similarly the moisture content on the previous period, what it is there, based on which the leachate quantity that it comes. So the leachate prediction is done mostly utilizing the strength of multilinear and ANN, and ANN worked very well. And good capturing in the nonlinearity, length of database governs when used as a data-driven model. So one of the good thing we have also, there are 2 PhD work which I guided on data mining application. One for ozone measurement, another is for reservoir operation. So what we found is, it is not the length of the data important. So even with the smaller data, that you may be able to get some good pattern which can be explained for the field application. So it is not necessary that always I should have 1 lakh data or 2 lakhs data. Even if you have 37 data or 28 data, there may be some pattern that it may be existing on that. So we can, the data mining is capable of recovery and build a model, even if it is very less amount of data, but there should be a good correlation. If there is no correlation, each one is different, then there is no point in using a data mining model. Okay, so what we have done is more on the, so how to improve the efficiency of prediction, whether there is any other approach. So normally we do a simple regression model, but that does not, it makes a lot of changes in the data. So it will, if I give you one outlier, that makes the entire linear regression different. So whereas in here data mining, it uses linear regression, but different group or different pattern. For each pattern, there will be a different linear equation. It is not, suppose I give some 200 data, it is not all the 200 one equation will be available. In the 200, some 30 may have a different pattern, 60 may have another pattern, another 30 may be in different pattern. So it will develop based on the pattern existing. It is not one equation, it may be 5 equations. So that means given the situation, it uses appropriate linear regression equation and use it. Whereas in the normal data statistics, we use all the data, but that may spoil the entire system as such, that one equation. So that's the main advantage with the data mining. So what we have done is we try to get the database, try to look for the temporal correlation and also chi-square evaluation. Then we have done some data cleaning in case it is missing. There are methods to put it, and pre-processing grouping based on the range. We ourselves did something. Then we use the algorithm classifier as well as ANN. We tried that. We tried all the method. Then finally we narrow down to this. Then evaluate the simulate leachate quantity. So suppose I have 100 data or 50 data, I take 30 data for training and 20 data for checking. Okay. Then you try to predict it, and if it is good, then you can utilize it on the future side. So this is Veka software thing. So I'll just explain that in the later part. This is the R statistics. So this also you can, R is also freely available. So you can, this advantage is you can use for any statistical other thing. If you want to compare, you can compare that very easily, like ARMA model and other. These are statistics. So what we have come out with is, so this is the actual and predicted what we have. This is data. So this is fitted data from the training system, whereas on the testing phase, we take only 10 data and then try to use that. You can just see there is a good correlation of 0.91, but may not be exactly the same thing maybe, but 0.78 is a good correlation. So it's not only the correlation, how far it is near to that. So that way it is predicting well. This is for the landfill B. So we could fit a neural network model. And similarly, this is for, but here we have used support vector machine. So this is a training phase 0.82, and testing phase it has been better improved also. It is not always the training phase, and because you have a lot of data. Here it is only a smaller data what we're using it, but 0.9, 0.82. So this is for landfill C, and landfill D, there is a poor correlation. So the variability is so, and the dependent variable, it's not having a good kind of system asset. So landfill A is much better because you can just see almost fitting very well. Okay, so that way this is clad sphere architecture. This is 6631. So this is more on input. This is hidden layers. 2 hidden layer, output is leachate quantity. So the input 6 is rainfall, waste quantity, and CC and MC of that particular period, and the leachate quantity of T-1, T-2. So and dependent variable is LQ T. So this T-2. So like that, you can put various combinations. So we find that there is a good way of classifying with the, it's not only the regression coefficient, this is Nash Shepley efficiency that shows how close with the predicted value with the actual value. That's a very good number. So that way, this and the learning rate and number of classification governs the performance of the model. So this is the first case study. Just 1 minute. The second case study is more on with your interest, maybe much more, but of course, solid waste landfill also is of your interest. So this is try to find out what will be the pile capacity, expected pile capacity, given the different conditions. Okay, so knowing the soil profile, SPT attributes, and also all other data. Okay, so we can come out with what may be the other data. What we have got is the blow count and the mainly the pile length, diameter, wall thickness, area of pile toe, circumference, soft soil type and toe soil type, and length of blow gauge and penetration, all these data, and then finally come out with what may be the capacity, the pile capacity that it is there. So luckily, University of Ohio, there is somebody who did very good work on, I don't know, he did the PhD, but a lot of data. He has done it on his own for different systems and collected all this data. So they have also, it is not only for one type of file, so 3 type of files that it has been tested. One is steel pipe file and pre-stressed concrete file, and also the H file or H section file. So these 3 file type he could get, or he has listed a lot of data. So this data I have taken from website and then try to demonstrate how this can be utilized for a data mining tool as such. So this is all we have seen. So try to define the problem and preparing data, and then try to give the training set and testing set to verify the accuracy. So we have also used association rule. So this is an example. You can just see, I'm just giving if depth is 50 and capacity is, and perimeter is this much, length is this much, then the capacity is like this. So there are, this is one set of rule where the depth is, capacity is in 500 to 600 or 650 range. So like that, it can develop rules from the data set what we have. So, and the data inception. So we have 3 file. One is steel pile of H section, and steel pile of pipe section, and pre-stressed concrete pile. So we have the data of 28 piles, data from group 1, 27 from group 2, and 39 from group 3. Okay, and we have the schemata for all those things. This is what it is there for different file. So you can also go to this file data, and then you can, I just took it, but you can, there are many more data may be available in the net. So Veka was used to create a project for the geotechnical data mining model. The number of steps are needed, so which we have done it. So let me just explain that. So this is how a nation tree and cluster from this data, and the definition of the mining model parameters. So this is a neural network which gives the perimeter and the depth and so on, what will be the kind of file capacity. So this is the association rules for each type of, so even if it is 37 data, and there may be some 3 data may be related together. So sometimes 5 data may be related together. If capacity is this much, which are all the data that it is there. So that is what is called association rule. So if I can plot one capacity with what are the given data which contributes or which result in the capacity in this range, you can develop an associated rule. So you may develop, for that we have developed around 12 rules for this sometime for this 29 data. So this is the overall result of the curve. So this I'm happy to say that I have done it on my own. So neural network, Bayesian tree, clustering, association, and the measured data. So we have taken out of the 29, so 21 data and 8 data for this one, wherever you can make that. So this is only tested. So this is a H file, steel pipe files, and PSC file. So one of the good thing is this has good correlation, but you can just see here the Bayesian tree is not predicting well. So these two file, the Bayesian tree gives only one equal value. So it doesn't work on that. That means the Bayesian tree may not be a good one. On the other hand, the neural network, so it have and clustering, we have the data and association rule. So and measure data. So you can just see some of the best results of prediction are obtained by neural network model and association rule model. Both models have a high correlation coefficient of 0.9. So the Bayesian trees and other model perform poorly. The clustering mining model performs very well for the group of files and indicates a correlation coefficient of 0.88. Whereas in the steel pipe, correlation coefficient goes 0.93, association rule as 0.86. So again, the same way, Bayesian tree and 9 bias. So inadequate result. I think this also a good result, because a thing that it doesn't work also should be a good result as far as research is concerned, so that you need not try again. The clustering discrimination algorithm attains an acceptable prediction performance with a correlation of 0.82. Whereas on PSC files, the association rules was 0.89, clustering model as well as network model is 0.9 and 0.92. The Bayesian tree and naive Bayes performed the validation part. Okay. So here, let me just tell that. So after you install this Weka, this is the first screen that you will be getting it. Okay. So in that first screen, these are the thing that you will be utilizing. You can use Explorer, experimental, knowledge flow, and workbench, and simple query language investigation. But normally we use Explorer quite a lot. And if you want to do experimental, you can do that. So the second screen where, I just open the file, then you can click on it, open file, then desktop, I take H file CSV, then I'll be, you can choose the CSV. CSV is comma spaced limited file. So this, you can just click on it. Then next one, these are all the data: file length, depth, wall thickness, area of the file start, and file to, all those things, what it is there. And the last one should be given as a final result, what you want. So whichever the variable that you are giving, this you can give any way, but the last one, whatever it is, it automatically takes that as a dependent variable. Okay, whereas all others are independent variable. So once you get those data, you can also, for anything that you click, it shows minimum, maximum, mean, and standard deviation, just to cross check whether you have entered the data correctly. Then you can select multi-layer perceptron. You go to classifier, and in that function, I was telling the naive Bayes equation. So that is here. You have a lot of chances. The linear regression, multi-layer perceptron, support vector machine, and rules, again M5 rules, and Bayesian tree and 0R trees also, you can click on it. And here, anything that you click, it tells about what are all the points that it is there, you may have to give that. So once I give that, then I try to give the test set data. If you want to give, you can click on this. So the moment you click on it, there will be this also will become bright, and you can the set. If you click on it, then it will, you can open the file and use that file inside, and also you may have to put a start. So this is a predicted one. So I put 20 data and 7 data for prediction. So that is a supplied test data. So this is the actual one. The predicted is 570, and this actually 600, predicted is 615, 629, 649, 425, 399, 109, 112, 114, almost 114, 347, 338. So I think you get a good correlation coefficient of 0.99, and absolute error is 11.84, and root mean square. So you have the statistics, and also you can if I go back, you can just let me, these are all what it is there on the top. So this will be, you can get how each network that it is fitted, and the weights are also given. So you can develop your rules also on your own. So let me just click on this. I think I don't know whether screen share. Are you able to see the screen?
Sir, it is showing conclusion for GT case study.
Yeah, just 1 minute only.
Okay.
So this is, I am showing on my computer. Are you able to see the computer?
So the slide it is showing conclusions for GT case study. That is, we are able to see.
Let me just.
You can take another share, sir.
Right. I will go. I don't know how to share this particular screen. Okay, right.
Share screen and zoom it in this way. Later you can corresponding file.
You could see that?
No, sir. First you click the zoom icon. After that you can share your files here.
Yeah, right.
First share screen, later zoom icon.
Just 1 minute. Yeah. Let me
Now you open your corresponding file, sir.
I'm just seeing.
Okay.
Are you able to see my computer?
Yes, sir. Yes.
No? Huh?
Yes, sir.
Yeah.
Able to see. Sir.
Yeah, right. Now, if I am if I am clicking on the Weka thing, this is what it will come. Then I click Explorer. Then you get. So I open file. So I go to desktop. Then I go for CSV files. Then let us put H file. So this is what I open it. So this is what you will be seeing. So, and now if I want to classify, I supply the test data set. So set will be open file. This is a H file test. So this I put and then just close it. So more options, you have to give all those method and use the choose a plain text. Then you put OK. But these are all manual available. So you can, I'm just showing if I start, so this is not coming in. I have to choose, then function. Then I go for multi-layer perceptron. Then I do this. Okay. This is one of the problems that every time that you have to set. Okay. Now, if I do that, so this is what I have got the data. So whatever I was showing, you can just see here, just running. So if I want to store this, so you can just right click, then save result buffer. Then you can put any name, fetch ANN, then you can save it. And you can use Notepad and then see all those data. So if you want to have an associate or a cluster, that also you can, any cluster, there are many things are available. So on the Weka, if you look at classify, again you can do simple linear regression, SMO regression. Then in that, again you have meta rules. There are many rules are there. You can just choose anything. So you may have to make a lot of trial and error. If I am getting very good result, then there is no problem. But there sometime it may be, you may have to. So on the rules, in this particular thing, only 3 rules are there. So if I take M5 rules, okay, and then supply data set is done. Then if I start, so this also predicting, but you can just see the correlation is 0.9557. Then there is 580, 704, 600, 633. Here again, you can also, if I am click on that, it will tell what are those parameters. So these parameters also you can change. So each parameter, what it says, all those things that you can learn it. So here, if I can, this is some rule. I'm just giving a rule. If pi length is less than 30, then use this particular rule. Tested capacity will be equal to 3.8508 pi length and case number and also plus certain thing. Rule 3, if it is total capacity plus thing for other kind of thing. And if you look at it, capacity is less than 504.5, you can use this rule, which takes all the parameters. So there is a pattern. I am just giving a simple pattern. It's a 37. 3 rules are available. So these rules can be utilized for any time that if I want to know what will be the system and so on. Okay. I hope that people can work on it. I'll just close it. Then let me. Are you able to see the conclusions?
Yes, sir.
Yeah. So I just wanted to make my concluding remarks. Understand the data mining first. So it is a very good tool, especially for research or practical application for that matter. You can use this particular one rather than doing the same thing every time. You can use a data mining tool and then get a very good result. Use appropriate tool that best suits a problem in hand, not the other way around. Because I have the tool, don't try to fit every data on it. Start by solving simple problems first before moving into complex ones. Spend some time to explore and understand the data. Incorporate domain knowledge in your analysis. Avoid reinventing the wheel. Data preparation is very important for building effective tools, and data mining is an experimental iterative process, not ideal for fixed price projects. Try to tackle the problem with different analytic approaches. It's clever to solve complex problems with simple techniques. And this is very easy to learn. It's not very difficult to learn. So I think there is a good application not only for, in fact, we have also done one of the master students use data mining for predicting the accident in a traffic thing. So we have collected all the Chennai data and find out what may be the reasons which may cause the accident. Then we have given the suggestions how to modify that, maybe to reduce the accident asset. So there is every place that you can apply that. Vizag you can apply, Hyderabad you can apply. In fact, you can rate the accidents are very high. So so you have transportation application, water resource reservoir operation application, and ozone data. We have collected a lot of data, and there is a good kind of data mining application. So I'll stop here, and if you have any questions,
Thank you, sir.
Thank you very much.
Please stop the share. So
yeah.
Before question answer session, I will share the Google Form link. I request the participants to copy the Google Form link. Copy this Google Form link. Now you can send your questions through chat. Any questions?
So either you understood fully or you didn't understand anything.
No, sir. It is a very interesting new area.
Yeah.
So applicable to so many areas of civil engineering.
Yeah. Okay.
Because the area is new, they may not ask questions. That may be the reasons.
yeah. But I think there is a good potential to use this technique for all this.
Sir, there is one question. The software is suitable for cube testing.
Yes. You only thing is you have to have a lot of data. Maybe at least, I don't say with 5 data I should do that. But if you have more data, then you can make an attempt to find out whether it works very well. It will work because we have done with a lot of data that it works very well. Right.
Sir, there
It
is
is
another
possible.
question. Another question. Veka is downloadable. How to
Veka is
download?
downloadable. R is downloadable. Miner also is. Whatever I said at the last, these are all freely available. You can utilize it. Okay. So Veka is free. You can just put Veka and free download. Then you will get. It was developed by Stockholm Environmental Institute, so it is freely available. So there is no charge that it is available. It is freely, you can download it. We have done, in fact, 2 of my students, PhD students, use Veka and then did their analysis. There was some question, or it's a comment from Sanjay Gupta that it's a new area with high potential for use in industry and also use with cost and boundary value. Thanks. Yes. The data what you are, but one of the good thing with this is we don't throw away some data because it is high or something. There may be some reason for that. So wherever we really leave out some data, but we should learn something from that data also. So that is a main logic in data mining. So rather than putting a simple boundary, so put all the data. There may be something that I should learn with this outlier itself. That's what the point that it is here. Thank you for the comment. Right. So I think there was what are the storage requirements? We depend on cloud. So in fact, storage, any simple computer, in fact, I have used around 40,000 data, and in 40,000 on the column wise, another 10 column, 10 by 40,000, there was no issue. The Veka can work very well. In fact, mind map is nothing but the Dyson tree. Okay, so you can also develop a mind map and then see how your data mining result is coming based on tree. Then you can just see whether your mind map is coinciding with this. It is possible that, but mind map is mainly from reasoning. But here it try to find reason what it is there. Okay, so. But on the other hand, if you have a cloud, you can download from the cloud that you can take it also, and you can send the result also into the cloud. But we need a software for that. Okay. But people are using that in UK. They predict the flood and then send it in the cloud, which goes to every person in that particular community. So he knows that when the flood will come at that particular location and where the flood is there and so on. So that way they compute it and push it into the cloud so that everyone knows about it. So that's also possible. Okay. Any other questions?
There are no further questions.
Okay.
So, I'm thankful to you, sir, for excellent presentations and question answer session at the end.
Thank you very much. Thank you very much, Professor Rao.
So very interesting area, new area. So utilizing the data and there are so many applications. So thank you to participants. Thank you to Professor S. Mohan. Thank you,
somebody has asked a question
okay.
that geotechnical experimental research, how data. In fact, these are all experimental data. What I have used a file is all experimental data. So from that, you try to find out whether there is some pattern. So rather than we have used earlier only simple regression, but now I can put the same data into data mining. It is not one equation I fit it. I may fit for many, it may be 3 or 4 regression lines and different ranges or different conditions. So it may be, you will be getting more knowledge rather than giving a one single knowledge, single statement. That's why. So, so the PG student, anytime once they get the data, instead of developing their model, they can use this. They can use this particular one for analyzing the data set, experimental data. That's what we have done. We have measured the air quality, or especially ozone, and then we have tried to find out what is the relationship. That we have used data mining and then got. In fact, it worked very well rather than any other existing models. So my publication list is there in my IIT website. Somebody asked publication list, can you share? It's there in my IIT Department of Civil Engineering. If you go and then click on it, it will be there. If you want a particular publication, please let me know, then I will give that. Even department website, my email will be there. What is the present situation in India about use in government organization? So I think government organization takes more time. So now it is only started in the research. So there are very good people who are working on this particular area, especially our computer science people. And there is a lot of activity on utilizing this data mining tool. I think all of us, we should start. Okay. So not only for, I would always say that it's not only for research, but for practical industrial application. You collected a lot of data. Please use that data mining and then get some good knowledge from that particular one. Okay. Thank you very much. So if there are no
Thank
other,
you, sir.
yeah, right. Thank you very
Thank you.
much. So
Thank you, Manandal. I will end this session.
Right. Great. Right.